Hi everyone. Today we're gonna look at a topic called numerical integration. Okay, so you have looked into my previous video or other videos on numerical differentiation, but numerical integration here refer to how to solve or how to evaluate an integral by using approximation approach. Okay, when I say approximation means numerical methods. Okay, so we know that the solution to this analytically if given by integral of fx, big F minus fa. Now this integral tells you the area under the curve. Okay, but sometimes you cannot find the analytical solution due to complicated approximation in integrand. For example, how do you integrate this? I'm not saying it's not possible. We're not going to discuss about how to find it. But when it comes to a situation like this, how do you evaluate this integral? It can be complicated. So it's easier to evaluate the integral by approximate means or using numerical methods to solve it. So that's what we're going to look at in this topic. Okay, so we want to find the area under the curve using numerical methods. So there are few methods that you can look at. So we have Newton-Cotes formula without n subinterval. Okay, so we have Newton-Cotes formulas. So without n subintervals, there are few. We have trapezoidal, we have midpoint, and we have Simpson's rule. Okay, so we'll look at these three first. So, for example, if you have a trapezoidal rule, so trapezoidal rule is given by the area given by average length of a parallel side times distance. Okay, let's see, I'm looking at this integral. 0 is square root 1 minus x squared dx. Now, this can be solved, but it will be a bit complicated. I'm not going to show you how to solve this at the moment here. So, your analytic solution will be arc sine A plus A square root 1 over A squared. Okay, but I'm going to show you that if I plot this graph here, okay, the area or the graph of this, okay, this is let's say this is my 0 is here, just back up a bit. Okay, so this is my 0, this is my y, this is my x. Okay, let's say I have some values here. So the interval, this is my b interval, so this is 0 point something. So let's have the graph here. This is 1. So when x is 0, I have 1, y is 1. So my graph should, let's say, have a curve like this. Okay, so let's have this curve. So whatever it is, this is my b. Okay, so in this case, this is my a, not b. Okay, 0 to a, 0 to a. Okay, so I have this curve here. Now what trapezoidal does, okay, so the area under, so this is my curve for y equals to square root 1 minus x squared. Now this is what trapezoidal rule does. So let's find the area for this curve by using, okay, I call this whole thing here t, by t. Okay, trapezoidal rule is given by the area so we have t equals to b minus a fa plus fb divided by 2. Okay, I need two points. So this is my A, this is my B. Okay, I need to find FB, FA, and then use this formula. You will get the area under this curve for this curve here. I'm assuming this is y equals to 1 minus x squared. Okay? Now you can see that the area is not quite fully covered, right? It's just not that accurate, but that's how trapezoidal rule works without n subinterval. I mean, I'm not dividing it into a few block with n intervals. Okay, that's composite trapezoidal rule. We're going to look at it later. Okay, now if I have a midpoint rule, now midpoint rule works like this. So take use black here. Okay, okay, so midpoint rule, whatever the midpoint, so it find the area under the curve for the midpoint. Okay, slightly over now. Okay, the area is the midpoint rule is given as m equals to b minus a f of a plus b over 2. Okay, so take the midpoint value here for a plus b over 2. Now this is the f of a plus b over 2. Okay, now this is a midpoint and Simpson rule. Now midpoint and trapezoidal rule. Now Simpson rule, both of this, okay, let me just say both of these are order 2. Order 2. Now we have Simpson rule which is order 4, which should be slightly accurate. Simpson rule takes the combination of midpoint and trapezoidal. Okay, it's given by S equals to B minus A over 6 FA plus 4 F of A plus B over 2 plus FB. Okay, so this is Simpson rule. Simpson rule, which is order 4. Okay, so what Simpson, so the graph is getting messy here, but so it takes the midpoint and the trapezoidal, take the area of the midpoint and the area of the trapezoidal to get the area for this whatever curve is. Okay, so This is okay, but the results are not that accurate because it's not covered fully, the interval. So I can show you by looking at one example here. So the example here is this. So let's say find the approximation to 0 pi over 2 cos x dx by using trapezoidal, midpoint, and Simpson. Okay, we want to see which one gives close to the exact. Now we can integrate this easily. When you integrate this, you will get the exact solution. Integrate cos x, okay, will give you sine x 0 pi over 2. So sine pi over 2, 1. Sine 0 is 0. Okay, so use this as our checking point here. So we know this is exact. Okay, let's use trapezoidal rule first. Okay, trapezoidal rule, T is b minus a, f a plus f b divided by 2. Okay, so you see here, our interval is a is 0. So we have a is 0, b is pi over 2. So we have pi over 2 minus 0, f of 0 plus f of pi over 2 divided by 2. So we have, this is a function f. Okay, this is my f. So we have cos 0 plus cos pi over 2 divided by 2. So cos 0 is 1. Okay, this is half here. So we have pi over 4. Okay, so this will give me to decimal point 0.78539. Okay, use your calculator to find the answer. Now midpoint, m equals to b minus a, f of a plus b over 2. Okay, so we have pi over 2 minus 0. F of 0 plus pi over 2 divided by 2. So we have f of pi over 4. So pi over 2 cos pi over 4. So pressing the calculator will give you 1.110721. Okay, the exact solution is 1. Now let's try. I think I have a little bit more of time. Let's try Simpson rule here. I hope Simpson rule gives towards the solution. So we have b minus a over 6, fa plus 4f, a plus b over 2. So we know it's pi over 4 plus f, b is pi over 2. Okay, so a is 0, cos 0 is 1. So we have pi over 2 minus 0 over 6. I have cos 0 plus 4 cos pi over 4 plus cos pi over 2. Now cos pi over 2 is 0, so and cos 0 is 1, so we have pi over 12 here, 6 times 2 here, and then we have cos 0 is 1. 4 times cos pi over 4, use your calculator to get the answer, 2.8284. Okay, by doing this arithmetic operation gives you 1.0023. So definitely Simpson rule, which is order 4 method, gives you closer to the exact solution. So you can check this by computing the error, the numerical errors. So we have error, which is absolute error, approximation, or your numerical method, minus with the exact solution. Now the exact solution here, exact solution for this interval, we've already I've already stated earlier on, is given by, it is given as 1, okay, which is the integral from 0 to pi over 2 cos x dx. You integrate this, gives you 1. So that's our exact solution. Now we want to compare with all these 3 methods. So we have first ET, error for the trapezoidal rule. We have the approximate solution we have obtained is 0.785398. So this is the trapezoidal that we obtained, minus with 1, minus with the exact solution, which is 1. That gives you 0.2146 something. Okay, so the error is very big here, and for M we have 1.110721 minus 1. Okay, so the error for the midpoint rule is given by 0.1107. Okay, now lastly, the error for the Simpson rule, which is this one, the approximate given by 1.0023 minus 1.0000. Okay, this will give you 0.0023. Now we can see that by comparing the numerical error, Simpson rule gives the smallest error. Okay, obviously this is true because Simpson rule is order 4, so it should give correct to the exact better than this trapezoidal and midpoint rule. Okay, so even the Simpson rule is good, but midpoint and trapezoidal rule can be modified such that it can give to the exact solution. That's when this composite rule comes in. Okay, so we want to look at composite rule.